a while since, well, I was invited a few times to submit talks, and each time I couldn't make it. So this time I'm really happy to be here with you. We're going to speak about webhooks. Webhooks, I mean, most of you are probably familiar with this concept, but perhaps it's actually not as trivial as it may seem, both to implement and to consume. So that's what we're going to have a look at. I am Guillaume Laforge. I'm a developer advocate for Google Cloud, but usually people know me best for the fact I co-created the Apache Groovy programming language, and I'm also a Java champion. Yeah, there are a few here. That's great. So it's an introduction. It's not a very thorough and complicated topic, but there are certain things we don't necessarily have in mind when we think about webhooks. As you can see, there's the link bit.ly/webhooks-GeeCON. So if you want to have a look at the slides afterwards, don't hesitate. I'll show that kind of slide once in a while in the presentation, so you'll get a chance to copy that link. All right. So let's start with a little definition. So what is a webhook? So it's when you ask some service provider to notify you via some HTTP callback, and you give an actual URL to that HTTP callback. So you have some kind of server running somewhere, and you're gonna be called when there's an event which occurs. Okay, that's a basic definition. And it's a simple way to connect apps together. So if you want to do server-to-server notification, that's a nice solution. I say real-time. It's not things like WebSockets and such, because it's more for client-to-server communication, right? But it's really server-to-server communication. Let's take a quick example. There's Twilio, which is a platform for sending, receiving text messages or even calls. What happens is that a user with a phone sends an SMS message to a Twilio number, a phone number, and then you have registered a URL that Twilio will call when a message arrives. So this is well, the message comes here, then you're being called via this HTTP request. I'm not sure you see the little arrow a little bit. And then your app replies, okay, or some reply, and then Twilio can reply back. So this is really this part between Twilio and your app. This is about this communication. There are many other examples, for example, of webhooks in the payment solutions. So when you have a payment through, let's say, Stripe, your app is going to be called. When you're sending emails via SendGrid, MailChimp, etc., you can also be called or get notified if someone opens the email that's been sent. You have webhooks for things like CI/CD platforms to be notified when the build succeeds or fails, and things like chat messages, whether it's like on the website when you see the pop-up like I want to chat with someone on the website, or things like Dialogflow, for example, if you want to build some chat interactions on the smart devices like Google Home and that kind of stuff, you can do that as well, thanks to webhooks. Okay. So webhooks have some advantages. So as I mentioned, it's real time. What's interesting is that you are notified right away when something happens, in real time or near real time. What's nice with that is that I mean, it's going to be explained more in the next slide, actually. You don't have to poll the service provider like every minute or something like that, or every hour or every second, why not? Because you're going to be called, actually, so you don't have to do that work. So there's only one call from the service provider to you rather than you making 10 or 100 calls. So it's also nice for saving CPU, bandwidth, etc. And also if you were polling like once every minute, you're going to be called right away rather than waiting perhaps up to 1 minute to get the notification of the event. So it's a nice aspect that there's no polling going on. Also, it's only, well, this one is perhaps less relevant, but it's only those who are interested in subscribing to events that are notified. So from the service provider perspective, we only ping those that are interested and not every possible consumers. But well, this one is a bit weaker as an argument. In terms of inconvenience, there are some as well. So when you're writing the webhook handler, you're not in control, so you're being called. So that's also part of the advantages, but still, you're not being called. That means that if something happens on the server side, perhaps you won't be called because actually the server doesn't work, or perhaps you didn't give the correct URL to your server, or more, let's say, critical. Let's say there are tons and tons of events flowing, and they're going to call you each time there's an event. Are you ready to get a big shitload of events in a very short interval of time? So it can be problematic if you're not able to scale, the same way as the events that are coming into your handler. What else? I think I wanted to mention something about control. I forget what it is. I'm going to take a little example with GitHub. You can define webhooks for your repositories. So for example, I want to be notified when there's a pull request, when some code was pushed, when a new version was created, a new issue has been created in the issue tracker, etc. You can be notified of those things. And I'm going to show you that with a little demo. Let's have a look at GitHub. So this is a dummy repository that I created. So as you see, there's really just a README file basically. And here in the settings, there's a webhooks menu, okay, where you can define your webhooks. So what I'm gonna do to test this actual webhook, I'm gonna use a little service that's pretty cool. It's called request bin. So it's a website that's gonna receive the webhook so that you can more easily debug things that are being sent by the service provider. So I'm creating a new webhook, or I could have used this one actually. And did it work? Did it create a new one? Yeah, never mind. So I think I can copy this one. Okay, I copy this URL. I'm going to give it here. I think I prefer JSON. I'm going to use a secret. Let's say GeeCON as a secret. It's super top secret. Don't tell anyone. I'm interested in all the possible events, or otherwise I have the list I showed on the slide. And okay, I'm gonna add the webhook. And okay, I have a new webhook here. And let's say I'm going back here. I'm going to change something here. Hello, webhooks playground for GeeCON. Okay, I'm going to save and commit that. And okay, and I should have received a new message here. So this one, the first one, it's actually a dummy call that GitHub does to check that the webhook actually works, your handler actually works. And what's interesting is that you can see the headers, you can see the raw payload, so you can inspect very easily what's going to be sent, so that you can implement the actual handler yourself by really double checking that it's the kind of payload you expect to receive. So requestbin.com. That's a very, very handy tool for double-checking things. All right. So now let's have a closer look at the various things to keep in mind when implementing webhooks. Sorry, things that can happen or best practices, etc. So the general steps for implementing webhooks. So of course, from the service provider perspective, you have to implement the webhook capability or pattern, let's say. You could provide an API. So here on GitHub, for example, you saw that there's a UI where I can define the URL, some parameters, etc., some settings. But you can also provide an API, a web API that you can call. And actually, the GitHub API is very complete, very thorough, and it does provide the ability to actually make a web API call to create a new webhook handler. So you have to, we'll talk more in details into some of the aspects to keep in mind for how you implement that kind of backend. From the consumer perspective, you also have to develop and deploy your handler and host it somewhere, whether it's on-premise, in the cloud, or wherever else. And you have to be ready to receive post requests. Then you have to register the handler's URL to the service provider, so whether it's through the UI, through a dedicated API, it doesn't matter much. And last but not least, whenever there's going to be an event that occurs, the service provider is going to call your handler. All right, so that's the basic strokes, big steps. So what should a handler do, or actually the service provider do, when your handler is replying, let's say, 404, 500 or something? What's going to happen is that the server, the provider, will likely retry to send the message because it wasn't delivered. And that's great. But on the other hand, if you, let's say, don't reply with 200, you might get lots and lots of messages. Perhaps it's because your handler is overloaded, or it's doing too much work, or lack of resources, or something. So if the service provider keeps on sending messages, perhaps it won't help you being more available to reply to those messages. So a trick from the service provider perspective is also to use exponential backup. So instead of resending the event information every, I don't know, 100 milliseconds, every second or something, you're going to send, okay, after 1 second, didn't work. I'm going to send after 2 seconds, or 4 seconds, 8 seconds, 16 seconds, etc. So it's a way to not put too much load on the actual handler. And once the handler actually replies, you can get back to the normal schedule so that you're as close as real time as possible. But you have, from the service provider perspective, to implement this retriability to resend something when the notification wasn't acknowledged. And so it's not necessarily just for one event, but imagine that a service provider sends really tons and tons of events per second, perhaps, generating a huge load on your handler. So many notifications, but perhaps you're not able to reply to those notifications, and the server is going to do even more retries, so adding even more load. So that's a bit problematic. There's a way which might be easier from the provider perspective and from the client as well, if it's easier to handle batches of messages together. So for example, I think that's the Facebook API that never sends more than one call per second. So you're sure you're going to have only one call per second, even if there are multiple events, but they are batched together in one call. So that's a possible mechanism that's interesting to put in place. Sometimes you may perhaps miss some calls. Perhaps your handler was down because you were updating it or redeploying or something, or there was some network interruption. So something that the provider can also do, perhaps via an API, a web API, it's to implement the pattern of the dead letter queue, so that perhaps after 10 retries, it won't retry forever to send a message. But perhaps you can have a log, some kind of trace that the consumers, the handler implementers, can have a look at to check that, okay, there was a few messages that I actually didn't receive. So then you can start debugging things and figuring out what went wrong. So that's this dead letter queue. It's not necessarily a queue for messages to be resent again, so it's not for retries, but just more as an audit log kind of solution. And so that's the advertisement part of the talk, because I'm working for Google, so I'm going to speak a little bit about some of our products. But so you can also use solutions like Kafka, etc., or in this case, Cloud PubSub, which I'm going to show you in a moment as well, which is a PubSub system providing topics, and you can have workers that are ready to read on this topic and then handle the messages. So that's a handy tool for also decoupling the actual fact of, let's say, receiving a notification via the HTTP URL, but you can then, or you can also create PubSub messages out of that, so that your handler can actually reply, okay, I received the message, I received the notification, then I'm sending the notifications, the payloads, through a PubSub queue, so that workers are actually able to treat those notifications. So you can decouple the actual receiving of the information from the actual treatment of the notification. Also, because there are retries and perhaps you received, let's say, you received the message, the handler received the message, but didn't acknowledge right away, or didn't send a 200 status or something. Perhaps the service provider is going to reply or send another notification with the very same notification if it's a retry. So you'd better have handlers that are idempotent, in the sense that if you receive the same message again, it shouldn't have any other side effect. You've already treated it, so you can keep track of which notifications you've actually received. So it's better to make the handlers idempotent, so that you don't, do let's say Stripe payments twice for a customer or something like this. It would be bad. In terms of security, it's very broad. I'm not going to dive very deep into that, but since here we're speaking about HTTP calls, to avoid having some top secret information flow and be, in clear text over the internet, you'd better use HTTPS. And I'm dreaming of a day when there's going to be just HTTPS and no more HTTP. From the handler perspective, since you are exposing a URL on the internet, you might want to be sure that, well, unless it's an internal system, and then you don't have to worry too much about it, potentially, but still, you're exposing a URL on the internet, and then you want to ensure that it's really only the very same person that sends you, or the service provider with a specific IP address that sends you those messages. So you can implement a whitelist of IP addresses. So it's not always possible. For example, I'm going to show you a little example later on where I'm using Cloud Functions, Google Cloud Functions, and I don't know, there's no commitment from Google to say we're going to send always with this IP from this IP address. So you can't always implement IP whitelisting, but that's one trick as well to restrict who can call you, because you don't want your URL to be called by anyone else apart from the service provider. Another thing as well to ensure that it's the right person that called you, that's signing request with potentially a user-provided secret. So that's what I did. So I already showed request bin, but I'm gonna show you something with the request we just did. So if you look at the request I received, let's look at the headers in particular. You're gonna see here X hub signature, SHA-1 equals, and then some hexadecimal string, right? What this is actually, it's an HMAC signature, which signs the digest of the body. So what I'm going to do is I'm going to copy the body, and there's a free tool on the internet here, HMAC generator. So if I paste here the body of my request, and I told you when I created the webhook that I used GeeCON as my secret key, and then for the digest I'm going to use SHA-1 because it's written SHA-1 equals blah blah blah. Compute HMAC. And then look at this 0, perhaps it's very small, but it's 0A55 something. And if I look here, I guess I can see it's 0A55, etc. That's the very same. So because only GitHub has that secret, or we both share the same secret, I'm sure that it's really GitHub that's calling me, okay? So that's pretty cool. Well, you could think as well that, okay, and there's replay. You could replay the very same request, of course, but still that's one additional measure to ensure that this message was really sent from GitHub. And if your handler is idempotent, even if someone replays it, it doesn't matter too much. Well, except in case of DDoS, but that's another topic entirely. So request being the signature, yes. Oh no, ngrok. I wanted to show you ngrok here as well, or is it later? No, I think I'm going to do that. Yeah, ngrok. That's another handy tool for debugging things. So ngrok. So it's a bit like request bin in a way for debugging things, but it's creating a kind of tunnel between the internet and your local machines. For example, I can have. So I'm developing locally my handler code. I'm running it on localhost, and then thanks to so this is the kind of admin interface here, and thanks to it's here a command line tool that actually creates the bridge between. So it gives me a publicly accessible URL, which is actually going to point at my local host. So that someone from, the security teams in your company might not necessarily be happy with that. At Google, I once let ngrok run on my machine, and the security went after me because I forgot to switch it off. And so this URL is going, I'm going to create a new. No, first of all, let's run my code here. So I created a little Micronaut application, and this is the Gradle build. So it's usually starting pretty fast. So it's gonna run on localhost 8080, and I launched ngrok on port 8080. Well, we don't see the command line anymore that was called. Let me show you what the actual code is. So it's very simple. So here I have a controller. Localhost colon 8080/webhook. It's going to be the URL that I'm going to use, and then the index. It's going to look at the body, and I'm just going to print the body, but I'm replying with a status code 200 OK. So that's what is running here. Do I have? So I can send something like here with a curl just to show you that it's gonna print the body that's sent via curl. So I'm gonna create a new webhook in GitHub with my playground here. Settings. webhooks and add a new webhook. So this is the URL slash webhook. I shouldn't forget the path. JSON. GeeCON again. Send me everything. I'm adding the webhook. And then, where is it? ngrok, it's here. Let's commit something again. Hello GeeCON, what else could I say? GeeCON Prague, yeah. Commit. And then I should see another post to my webhook here. And here in the web interface, the local web interface for ngrok, I can see the this one, yeah, because there's the dummy one to check the webhook works, and here that's the one I actually just made. So again, that's the same kind of information with the request bin tool. So, but that's just to give you an idea. So ngrok is a very handy tool if you want to test locally on your machine, but being called by the service provider. Okay, let's continue. And in general, just apply good security principles. You could also add authentication, authorization, and those general things, of course, in addition to if you want to have microservices discussing together, you know, it's probably better to add additional things, additional security measures. I won't dive further there. So some other best practices. So when you saw the payload here, let's say in ngrok, or so it's a medium-sized JSON document. But imagine, or especially if you use batching, etc., perhaps the payload could be pretty big. So with webhooks, you're notified just once when there's an event coming up, but you know, perhaps your events could be, I don't know, like a new picture that's been uploaded. Okay, I'm going to notify you because there's a new picture uploaded. But then are you going to send the whole bytes of the picture in the payload? Maybe not. So another pattern that exists, so either you put the actual payload in the event envelope itself, or you can also just give a URL to that, or at least to the URL of the resource that represents the event of, let's say, yeah, the new picture that's been uploaded. It's going to be the URL of the picture, for example. Could be that. So it's there's a name for this pattern, but that I forgot, like double fetch or something, which means that okay, you're notified that something happened, but you still have to do another call from the handler to actually get the data. Webhook handlers should answer rapidly, because if the service provider is waiting for you to answer, it cannot serve necessarily more handlers at the same time, because you only have a limited number of connections, for example. So you might have to scale that more horizontally more. And additionally, you could say that handlers should do nothing. So in the sense that they should just acknowledge that the notification was received, but not do the treatment. So for example, if your handler is supposed to be doing, let's take again the example of images. If you're supposed to be doing some image manipulation that takes seconds or a minute, why not? So you shouldn't wait for the full minute. You should just acknowledge, okay, I received it, and then I'm going to decouple the actual treatment of that information, that there's a new image that came up. Both from a handler perspective and a provider perspective, the consumer and the server, a good pattern is to enqueue those calls. So you acknowledge, you receive them, and then you and queue the actual treatment of that information. So you could use something like PubSub, or for example, on Google Cloud, there's also Cloud Tasks, which is also a way to prepare a kind of queue of tasks that have to be executed. The other thing as well that's interesting with a product like Cloud Task is that you can also apply some, let's say, heuristics, or define some settings for things like rate limitation. So, for example, if you have to ingest the incoming messages and store them, or let's say, another good example, if you want to tweet because there's an event that occurred, the Twitter API, there's a rate limitation. So you cannot send too many tweets. So you may have to rate limit the tweets that you send once you receive those notifications. And Cloud Task allows you to define rate limitations, for example. Yeah, that's the end of the advertisement for this part. So I'm here to talk about best practices, but Google is happy when I'm talking about our products. Yeah, the other thing. So we mentioned exponential backoff, or the exponential backoff, retries, etc. But the thing is that if you notice when you're a service provider that a particular handler is not responding, you should keep track of that. And at some point after, I don't know, perhaps 10 retries or something like this, you should just stop sending notifications because they won't be received anyway. And for example, on GitHub, well, I deleted it, but when I was doing my preparation a while ago, I had created a temporary URL with ngrok, and of course I stopped ngrok after I had finished developing my handler, and in the UI of GitHub there was some red link or something saying, okay, this webhook is inactive because it doesn't ever reply to my requests. Okay, but what if nobody calls a handler? Why is that? Is it because perhaps the service provider is down, but let's assume it's not. And the thing is that, let's say you're receiving an event once every day, once every week, once every month, or even just once an hour, never mind. The fact is that even for just one message once in a while, your handlers are running for nothing, because most of the time they are idle, they're not doing anything. So that's when your handlers might actually benefit from serverless solutions. So a serverless solution, a serverless compute solution is something where you deploy your code, whether it's a function, an app, a container, but it's only running when there are incoming HTTP requests, and you're build only when this code is actually running. And also you don't have to manage the infrastructure, provision servers, clusters, or whatever. There are a few products again that Google provides, for example, Cloud Functions. Here I'm within the Google Cloud Console, and where's my Functions tab? It's here. I created a few functions. So I created a webhook here. So here, instead of Micronaut, I did it in Node.js. Where's the code? Source, which is something very simple. So I just defined a bit of code that pretty prints basically the request header. Whoops, sorry, I'm moving a bit too much. The request headers and the request body. And if I commit something again, here, up, hello, GeeCON Prague, another commit. Okay, commit changes. And then I can go to the logs, the log viewer, and I should see So when is it? Yeah, that's like 10 minutes ago. No, it's just because I wasn't seeing the newer logs. So yeah, that should be this one, and I received well the payload here. All right. So it's very easy to actually add functions, and they are really just running when you need them, right? And your build when you need them, when they have been running. And also the nice aspect is that it's scaling proportionally to the usage, so you don't have to care too much about scaling yourself, because that's the cloud provider that does this. So I'm mentioning cloud functions because I work for Google, but you can obviously use Azure functions, AWS Lambda, etc. And I also had another example with PubSub. So if you, I mentioned that it's great to decouple the acknowledgement of the reception of an incoming event from the actual treatment of that event. So if you use PubSub, I can, so I created one source here. Oh, why I'm not seeing the, oh, there's a bug. Oh, perhaps I'm just disconnected somehow. Logged out, I mean. Sorry for that. And I just wanted to show a very simple, again, that's Node.js. I'm receiving the PubSub message, and then I'm going to output just the data payload of the PubSub message, which is encoded in base 64. And then, so here I'm using the UI, but of course I can put the code in a Git repository, push that, etc. And back to the logs, I can see. So I'm gonna launch the so ngrok, I don't need it anymore. So here I configured my project to be able to send test messages on a topic from Cloud PubSub, and then I'm gonna receive again 33, 36. It takes a few seconds to update. It's not really real time. I'm always complaining because I'd like it to be real time, but it takes like 5 seconds to update. And yeah, the payload was hello. Well, you don't see it's hello because it was, oh yeah, it's here. Yeah, you see it's hello. That's the message that I sent. All right, a quick demo of functions. So you could use Cloud Functions, you could use App Engine when you want to deploy apps, or you can also use a recent product called Cloud Run, where you can deploy containers. So all those things, functions, apps, and containers can run serverlessly with automatic, transparent scalability, with pay-as-you-go, and so on. No, stay in presentation mode, that was fine. Right, whatever. So, in summary, initially I wanted this talk to be more about just the server side of things, but when I was preparing it, I noticed that there are some best practices as well for the client side as well as for the server side. So here it's really just pretty much a summary of what we've talked about. Yeah, I think I didn't forget any of this. They are, so that's why it's interesting to copy this URL. I have some interesting resources there, so I won't go through all of them, but I have 2 pages of interesting resources. So just copy this URL, take a screenshot of this URL, and you'll get all the URLs of the resources, which are very interesting and cover most of these things. So it's a bit of my presentation is a bit of a collection of all those best practices. All right, and that's about it. So thanks for your attention. And yeah, I don't have a thank you slide. I should have added it. Let's have a look at, Slido. Is it Slido or Slido? How do you say? I don't know. Events order condition raise, how to handle. Yeah, it's something I should add perhaps in this presentation. So ordering can be tricky. From the service provider perspective, the events arrive at a certain time, and they know when the event actually occurred. So it's more on the handler side that perhaps, also because potentially of retries. So you could not receive the first message, then a second message, second notification arrives, but then the provider is going to retry the first message. So you might receive message 2 before message 1 because you couldn't treat message 1 when it was sent. So yeah, that's a problem. There are solutions or ways to do that with some time windows where you're waiting, you're looking at the events that are coming up, but only treating those events once the window is gone. There are also, for example, on Google Cloud, some solutions, some services like Dataflow, which does that kind of work for you. Race condition, not sure what you mean by race condition. Is it when you receive 2 messages at the same time or something like this? I don't know. Not sure. Yeah, so do you want to give some more details perhaps on this or not? Yeah. Yeah, so essentially about the ordering more than the actual parallel thing, concurrent thing. Okay, no more questions or any live question? No? Okay, so thanks and enjoy the final show.